Welcome to this video, dear learners. In this video, we'll be looking at introduction to organic chemistry. Now, organic chemistry is defined as the study of carbon-containing compounds, with the exception of oxides and carbides. Okay, so basically, what we're studying here is the element carbon and a lot of compounds that contain the element carbon. Now, why is carbon so special that it's studied alone here? Because carbon has got this special ability, okay, in that it can form 4 bonds. Okay, carbon can form 4 bonds. This allows it to react with a lot of substances, okay, due to this formation of 4 bonds. Okay, now for us to understand properly what organic chemistry is all about, okay, we need to understand what we call the language of organic chemistry. Okay, so it has its own type of language, and if you don't understand the language of anything, it's difficult to even understand what is being talked about in that particular topic. So we start with the language. Okay, as we are saying, organic chemistry has its own particular language. Okay, and there's a type of language you use whenever we are counting. Okay, since we are talking about the organic chemistry and it's a study of carbon containing compounds. Okay, so we always count the number of carbons in each and every particular point. I mean each and every particular compound. Okay, in each and every particular molecule compound that contains the element carbon. So when you look at this language here, it's just a way of counting, showing the number of what carbon atoms. Okay, so if there's one carbon atom like this one here, the name we use is called meth. Okay, if there are 2 carbon atoms, it's eth. If there are 3 carbon atoms, it's prop. 4 carbon atoms, but. 5 pent, 6 hex, 7 sept. Now sept here, sometimes they will use the word hept. 8 oct, 9 non, 10 deca, 11 and deca, 12 dodeca. Okay, so now this refers to the number of carbon atoms. So any element that, so these are what we call prefixes. Okay, a prefix, it's a word at the beginning. It's a small word that is at the beginning of the word. Okay, so now that we've looked at the prefixes, okay, now we need to pay attention to these, what we call the homologous series. Now these, we look at them as families. Okay, so we have a family of alkanes, a family of alkenes, a family of alkanols, and a family of carboxylic acid. So there are 5. The other one we won't discuss it in this video now, but what I want us to pay close attention is, so if this is a family, each and every family has got a surname. So this one here is a surname. Also, this one is a surname. This one also is a surname. Okay, but when it comes to the carboxylic acids, these ones, their surname, it's their surname is anoic. Okay, anoic. Okay, so now let's look at some more things to know on the language. So we said if a compound has 1 carbon, it will begin with meth. If it has 5 carbons, it will begin with pent. Okay, now depending on the family that it, so these are like the first names. Okay, and then these are the families. So when we get meth, N. Okay, when we get but, N, butene, butanol. Okay, so that is how we name these things. Now, just something to know, each time you see An, okay, An will tell you that a compound has a single bond between carbon atoms. Okay, and each time you see En, it will tell that a compound has got a double bond between carbon atoms. Okay, so when you look at this, there is An in the middle. So this tells you it's the single bond. So all single bonds are called the saturated. Okay, these are also called saturated hydrocarbons. Okay, saturated hydrocarbons, that is the other name. These ones, the other name, they are called unsaturated unsaturated hydrocarbons. What this simply means is that these have got all double bonds. These have got, these have got single bonds. These have got double bonds. Okay. Now, also here, AN will tell you that there is a single bond. Also here, there's a single bond. To look at that. Okay. So now, when we look at the first member here, which is called meth, that's the first member in the family. The surname you add ANE, ANE. So this we call it methane, okay? Methane. Now, meth, like I have said, simply means that compound contains only one carbon atoms, okay? One carbon atom. So now you are going to write, if it's the structure, like this, one carbon atom, okay? One carbon atom. The meth here, one carbon atom. And then the AN here tells us that there's a single bond. Now this one, since it only has one carbon, okay, and it is a hydrocarbon, this simply means that it's only made up of carbon and hydrogen. So we said carbon is special because it can form 4 bonds. So we show the bonds like this. Okay, we show the bonds. They are H, H. Why am I adding hydrogen on everything? Because it's a hydrocarbon. Okay, it's a hydrocarbon. Then when you go to the second one, earth. Okay, number 2 is earth. The surname ANE. Earth means what? 2 carbon atoms. So you're going to write 2 carbon atoms. Now, since there's AN here, AN, okay, what did we say? AN means there is only one bond, single bond. So we're going to put a single bond here. Now remember, carbon can form how many bonds? 4, okay? 4. There should be 4 bonds. So now when you look at this carbon, there is a bond here. So to make them 4, you add 1 there, 1 there, 1 there. Okay, the same thing, you add 1 there, 1 there, 1 there. So now you count for each carbon. This one has got how many bonds? 1, 2, 3, 4. This one, how many bonds? 1, 2, 3, 4. Okay, and now what you put here is simply the hydrogen, because these are hydrocarbons. They will have hydrogen all over there. Okay, so that is how you can come up with the elements. So now you can do the same for this one, this one, this one, this one, this one. Okay, let's just do one more. So prop, then ANE. Okay, so you have carbon, another carbon, another carbon. AN tells us there is a single bond everywhere. Now to make this one have 4 bonds, there is 1 here, so you add 3 there. Now this one in the middle, it has 2 bonds, so to make it 4, you add 2 more. This one has got 1. To make them 4, you add 3 more, and you put hydrogen everywhere. Okay, just like that. Okay, hydrogen everywhere. So this is what we call propane. Okay, now the molecular formulas are very simple. You just count, you write 1 carbon, how many hydrogen? There are 4. You just write it. The molecular formula is very simple. Okay, CH4. This one, how many carbon? 1, 2. So you write C2. Okay, then the hydrogen, 1, 2, 3, 4, 5, 6. You write H6. Okay, very, very simple. The same thing for propane. 1, 2, 3. You're going to write C4. 3. Then the hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. You write H8. Okay, and that's how you can write. So you can finish up to maybe the 10th one. No? Okay, up to the 10th one, looking at these. So the next one will be butane. Okay. Now when you go to the next family, this one, they are unsaturated and they should have a double bond. Okay, we said when there is En here, there should be a double bond. So for this one, you cannot form a double bond using only one carbon. So the first member, this one does not exist here. Okay, does not exist. So these, they begin from F. Okay, then you add the surname Ene. Okay, now for these ones, okay, Earth means there are two carbon atoms. So you write two carbon atoms. Then, because of the En, they have an En here. They should have at least one double bond. So you're going to put a double bond here. Now, the double bond here, meaning if you count the number of bonds for this single carbon, it's 1, 2. So to make them 4, we add 1 there and 1 there. Okay, so we always put hydrogen. Okay, also here we add 1 there, we put hydrogen, the other one there. So always, each and every carbon should have 4 bonds. So this one, you count them 1, 2, 3, 4. Okay, also this one 1, 2, 3, 4. So it has 4 bonds. You go to the next member, which is prop. Remember we said this one here does not exist under the alkene family. So propene, okay, prop means 3. So you show them like that, this carbon. Now, because of the En here, you should put a double bond at least at one particular point. So we'll put the double bond here. The next one can have a single bond. So you put it at least at one particular point. Now this one here, how many bonds does it have? 1, 2. To make them 4, you add 1 here and the other one there. Okay. So notice the way I'm making them like this. I'm not making them straight. You can write them straight if you wish to. Okay. This one, how many bonds does it have? 1, 2, 3. So it only needs 1. You can put it down. Okay. Add 1 here. So it has 4. This one, it has 1 bond. How many bonds does it need to make 4? 3. So put 1 there, another one there, another one there. Okay. So this is how you write the structure of propene. Okay. You go to the next one, which is 4 but the surname is Ene, butene. Okay, so you write 4 carbon atoms, 1, 2, 3, 4. Like I said, you put a double bond at least at one point, so we can put it here. This one, how many bonds? 2. It needs 2 more. You add 1 there, 1 there. This, okay, the rest are going to have single bonds. This one, how many bonds does it have? 1, 2, 3. You can put 1 there. This one, how many bonds does it have? 2. To make 4, you put 1 there, 1 there. This one, it has 1 bond. To make 4, it needs 3. You put 1 there, 1 there, 1 there. Okay, then you put your hydrogens at each and every bond. You put these hydrogens. Okay, and this is what we call butene. Now, the molecular formula is very simple. When you look at the structure, you already know what to write. 2 carbons, so you write them like this. Okay, CH2. Okay, how many hydrogens? 1, 2, 3, 4. So you write them like this. Okay, and propene, 1, 2, 3. So this one is basically C3. How many hydrogen? 1, 2, 3, 4, 5, 6. H6. Okay, this one, 1, 2, 3, 4. Just write C4. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8. H8. Okay, and that is how write the molecular formula for these. Okay, then now we go to the alkanols. Okay, the alkanols. So now the alkanols, okay, these are alcohols. Okay, now the alcohols, they're also called a group of what? Alcohols. Okay, alcohols. Okay, now These are a bit different from the first ones, because these, if you notice, they are just made up of two elements, carbon and hydrogen. Okay, but here there is an oxygen which comes in, and this oxygen comes because of the functional group. The functional group, okay, the functional group, which is the hydroxyl group, the OH. Okay, they have an hydroxyl group. Okay, so the way you do this one, you start the first member. I'm sure you still remember. Will be meth. The surname is ano, so methanol. Okay. Now meth tells you that there's only one carbon. So you write one carbon. Now remember, there's a functional group. You add it to the compound. Okay. So you're going to add the functional group to the compound. Okay. Now again, look at the number of carbon atoms. The bonds, sorry. There's one bond here. So this one can have another bond here, another bond there. So this is H, H. So this is how you write methanol, the first member, okay? And you can write it, the molecular formula here, 1, 2, 3. So it will be carbon, the hydrogen, there are 3 of them. And then you add the hydroxyl, okay? This is the structure and the molecular formula, okay? So you can go over to the next member, which is F. Okay, the surname ano. Okay, so ethanol, sorry, ethanol. Ethanol tells you 2 carbon atoms. You are going to write 2 carbon atoms. Now, AN, it's not double, it's a single bond. So put a single bond. After putting a single bond, what should come next? The functional group. Okay, the functional group. After you do the functional group, now you look at how many bonds. This one has got 1 bond. It will need 3 more. So you add 1 there, 1 there, 1 there. So you have H, H, H. Okay. This one, it has 2 bonds, so you can just put 1 here and 1 there. So that's how you write the famous compound called ethanol. Okay, ethanol. So ethanol, C2, okay, 2 carbon atoms, C2. And then H, how many are there? 1, 2, 3, 4, 5. So you write 5. The functional group always at the end. Okay, so this is how you write ethanol. Okay, how you write ethanol. We do one more last one on this group. So number 3, I'm sure you know. So this is the counting that we are following. Method. So number 3 is prop. Okay, so we just write prop. The surname is ano. So it reads as propano. Okay, propano. So prop tells you there are 3 carbon atoms. 1, 2, 3. AN tells you everywhere it's a single bond. After you add these, the next thing you add is a functional group. Okay, after the functional group now, this one has how many bonds? 1. So you add 3 more to make them 4. This one has got 2 bonds on the sides. You add 2 more to make them 4. This one has got 2 bonds on the sides. So you add 2 more again to make them 4. Then you fill the gaps everywhere with hydrogen. Okay, so this is what we call propanol. Okay, and the molecular formula for propanol, see how many carbon atoms. Prop is 3, so you write 3. Hydrogen 6, 7, so you write H 7, and then the OH. So that is how you write propanol. Okay, this is how you write propanol. Now we go to the next member. Okay, the next family of what we call carboxylic acids. Carboxylic acids, a bit similar to the alcohols, except that these their functional group. Okay, they also have a functional group. Their functional group is the COOH. Okay, we call it the carboxyl group. Call it the carboxyl group, and it is also called as the okay, we can show it in structure form. We write it like this. It has a double bond, O, so CO and then OH, then the OH, which comes there like that. So that is the functional group. Okay, so again, this one, we are going to start the first member. Number one is meth. Here their surname is anoic, so we're going to write methanoic. They are acids, so we write methanoic acid because the first member. So meth means one, so you write one carbon. Okay, then you add the functional group on this same carbon, so OOH. Now remember what we said, carbon should have how many bonds? 4. Okay, how many bonds are here? 1, 2, 3. So it needs one more, which comes here. This is methanoic acid, and we write it as H, this H here, and then COOH, the functional group. As simple as that. Okay, that's the molecular formula. Then the next member would be F. Family name anoic. So ethanoic acid. Eth means 2 carbon. An, they have a single bond. Then you add the functional group. Here it has, so this one's already filled. It has 4 bonds. 1, 2, 3, 4. Now this one, it has 1 bond, so you add 3 more to make them 4, like that. And this one, you write it as CH1, 2, 3. So CH3, and then COOH. Okay, that is ethanoic acid. Okay, and the last one that we'll do is prop, then anoic acid. So this you write as C. Okay, the last one, you add the functional group. Single bonds everywhere. Okay, this one needs 3 more bonds to make them 4. This one needs 2 more bonds. Okay, so that is propanoic acid structure. 1, 2. So you write this one will be C2. Okay, C2. The H are 1, 2, 3, 4, 5. H5. Okay, and then COOH. Okay, as simple as that. Okay, so these are the first what we've looked at so far. We've looked at the alkenes. Okay, the alkenes, and then the alkanes, and the alkenes, and the alkanols, and then the carboxylic acids. Okay, now there is also a formula that we use. We call it the general formula. Let's look at the general formula here. So the general formulas are used to write the molecular formula, but we were writing the molecular formula based on the structure, which is very easy. So the molecular formula here, the general formula, it is CnH2n, okay, plus 2 for this family alone. Okay, so let's try to make propane, okay, using the general formula. So propane, prop means N is equal to 3, the carbon atoms. So you put 3 here, C3H, 2 by 3, that is 6, plus 2, that is 8. Okay, so this is what we've got in for propane, which is the same thing we had here on the structure. Okay, so you can use the general formula, or the structure can give you the structure. The structure actually gives you everything. Okay, and you can get the structure just from the name. Okay, here the general formula is CnH2n. Okay, here the general formula is CnH2n plus 1 OH. Okay, and this one, the general formula is Cn, but this one is confusing. If you use the general formula, you try to use the general formula and you see what you have. Okay, that's why I like drawing the structure first and then you go to the general formula. Okay, so that's all that we had to do in this video. So in our next video, look at the next family, which is the esters. Okay, the fifth homologous series. Okay, so just make sure you know the language here, what they mean, and also this part, when you develop that interest to know the name and what the name actually means, it will help you now to understand. Just by looking at the name, you can tell even the structure and the molecular formula from there.